Hello. Today we're going to talk about Chapter 16-4, which is on page 5 of your notes packet. And what we're going to talk about today is the most important part of Chapter 16. We're going to talk about the probability of one event occurring that has two different outcomes. And the two different outcomes could be either a success or a failure in all different sorts of ways. So we're going to talk about what all this means. For a given event, and these events are things like tossing a coin, or rolling a dice, or playing a game, or shooting a basketball. So all of these different events could happen. Like if you roll the dice, maybe we're trying to get a 6 when we roll a dice. So you either would get a 6 or you wouldn't get a 6. Or maybe we're flipping a coin and you're trying to get heads. So we would be flipping the coin would be the event, and the outcome could be we would get heads or we wouldn't get heads. Or the event could be playing a game, we'd either win or lose. Or shooting a basket, we'd either make the basket or miss the basket. So that's what I'm talking about. One event, two outcomes. Could be a whole bunch of different possibilities. So for a given event, the probability of success is P. So if we're successful, like if we're trying to roll a 6 on the die, the probability of that success would be 1 out of 6. And the probability of failure is called Q. So we're going to assign these variables, probability of success and failure. And then if you want to figure out how to get Q, hopefully you know that when you add two probabilities, a success and a failure, you're going to get up to 100% or 1. But we'll talk about all of this in the examples. Then what we're trying to figure out is the probability of exactly, which is a key keyword in this, exactly our successes in n independent trials. So what we have is 4 variables, and I know this is very confusing at first, but once you go through some of these examples, I hope you'll get the knack of it. You're going to have 4 variables. You're going to have a P and a Q. The P and the Q will add up to 1 always because these are probabilities. You're going to have the variable R and the variable N, and you're looking for R successes in how many different times you try something, like how many different times you shoot a basket. Maybe, three shots you'll make. So N means the total number of times that you perform this activity or you do the activity. Like how many times do you roll the dice? That's what N is. R is the total number of successes you're looking for. So that is the number of successes, which is indicated above. P is the probability of a success in one attempt or one trial. And Q is the probability of failure. If you're not successful, you're failing, not you, but when you're trying to do this activity. So remember, P plus Q always adds up to 1 or 100%. So this is really, really important. That's why we've got this star here. This is an important formula that you have to know. It's not given on a reference sheet. So this is something that you've got to have in your mind. This is not on a reference sheet. And the formula goes like this. This is a formula. NCR, which is combinations, that's the NCR button on the calculator. So whatever this N value is, whatever this R value is, like maybe N is 8 and R is 3, you'd say 8C3. And then this P is the probability of a success. You raise that up to the power of R. And then Q is the probability of failure. You raise that power up to the n minus r power. So you have a couple of exponents here, and you have an NCR, which is combinations. But we'll be saying this formula over and over again during this part of the chapter. NCR, P to the R, Q to the n minus r. All three of these things are multiplied together. The NCR will have a value. You multiply it by P to the R. You multiply that by Q to the R. But you can put it all on one line of the calculator. And I'll show you what exactly that means. Let's say you have a coin. Let's say you just have a penny. And we're going to toss a penny 3 times. Flip, 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 3 times. What is the probability that after you toss it 3 times, exactly twice you're going to land on heads, or the coin will be landing on heads? So when you see this keyword exactly, you think to yourself, okay, we're going to have to use this formula NCR, P to the R, Q to the n minus R. And the n is the total number of times you perform that activity. Well, you're tossing a die 3 times, so n is going to be equal to 3 because you have 3 tosses. R is the number of successes. We want exactly 2 heads. The number that comes after the word exactly will always be your R value. So we want 2 successes, 2 heads on 3 tosses. The P is the probability of getting or flipping heads on exactly 1 attempt. So if we try to figure out what the probability of flipping heads is on a penny, the probability of flipping heads is 1/2. And the probability of not flipping heads is also 1/2. So there are your values of the 4 variables that you need for this formula. And then it's just a matter of substitution. You're going to substitute 3 in for n and 2 in for r. So you have 3C2. You're going to multiply that by 1/2 to the 2nd power because it's P to the R power. And then it's Q, which is 1/2, to the n minus r. Well, n minus r is 3 minus 2, and 3 minus 2 is 1. So this is what we're going to take into our calculator and figure out the probability of getting exactly 2 heads if we toss the dice 3 times. So let's do our 3C2, 3 math PRB, NCR2. There's 3C2, and you don't even need parentheses. Well, I'm sorry, as I open it up, times, let's use our fraction button. Let's do 1/2 to the 2nd. So 3C2 times 1/2 to the 2nd times 1/2 to the 1st power. Oops. To the power of 1. So in your calculator goes exactly what we just put on our paper. 3C2 times 1/2 to the 2 times 1/2 to the 1. And our answer is 3 out of 8. So we have a 3 in 8 chance of getting exactly 2 heads when we flip the coin 3 times. Now what we want to do is figure out the probability that we'll get, after flipping a coin 3 times, we get exactly 3 heads. Well, we're still flipping the coin 3 times, so n is still 3. This time, the number of successes is also 3 because we want to get exactly 3. So the number that comes after the word exactly is always our R value. The probability of getting heads, of flipping heads on 1 flip of a coin is still 1/2. This P doesn't change and this Q doesn't change, even though we're trying to get 3 heads this time. The only thing that changes is that we're trying to get 3 heads instead of 2. So the formula goes NCR, so 3C3 times P to the R. This time it's 1/2 to the 3rd power times Q to the n minus r. Well, 3 minus 3, n minus r is 0. So it's 1/2 to the 0 power. and that will give us our probability. So let's, I'm just going to push the up arrow button so I don't have to type everything all over again, because really the only thing that changes here is instead of 3c2, we're going to do 3c3. And instead of 1/2 to the 2, we're going to do 1/2 to the 3rd. And the second 1/2, we're going to raise that power to the 0 power. And that answer is 1 out of 8. So we have a 1 in 8 chance of flipping 3 heads after we flip a coin 3 times. This is theoretical probability. Now let's say we want to flip tails exactly once. So we still are flipping the coin 3 times. The R value is we want exactly 1 tail. The probability of flipping tails this time instead of heads is still 1/2 after we flip a coin once, and Q must be also 1/2 because P plus Q always adds up to 1. So now what we have is 3C1 times 1/2 to the R is 1, times Q to the N minus R, 3 minus 1 is 2. So this is what we're going to put on our calculator this time, which I'm just going to hit the up arrow button and overstrike. So we have 3C1 times 1/2 to the 1 times 1/2 to the 3 minus 1, which is 2. So if we put that in our calculator, we still have a 3 out of 8 chance. And if you think about this logically, if you flip exactly 2 heads, then you must be flipping exactly 3 tails if you flip the coin 3 times. So the probabilities should be equal to each other. And they are. Now we're going to have a dice problem. Let's say we roll a dice 4 times. That means N is equal to 4 because we're performing this activity of rolling the dice 4 times. So what is the probability of getting exactly 2? Now box off that exactly 2 because that's going to be our R value. We're rolling the dice 4 times, so N is 4. We want to get exactly 2 something or other. Well, what do we want to get exactly 2 of? We exactly want to get 2 3s. So this is always a debatable issue with my classes. What is the probability? Now you have to remember that the probability, the p-value, the probability of a success in one attempt. So if we roll the die 1 time, what's the probability of getting a 3? So this is the probability of getting a 3 on a dice. And what's the probability of getting a 3 on a dice? It is 1 out of 6. So that's your p-value. Now Q and P have to add up to 1. So 1/6 plus what is equal to 1? 1/6 plus 5/6 is equal to 1. So the P is 1/6 and the Q is 5/6 in this situation. So just think about when you're trying to figure out P, when you're performing this activity exactly once, what is your probability of getting a success, which is a rolling of a 3? So we have NCR 4C2 times P to the R power times Q, which is 5/6, to the N minus R. 4 minus 2 is 2. So we're going to put that in our calculator this time. I'm just, again, going to overstrike all of those numbers. This time we have to overstrike a bunch more. So we have 4C2 times 1/6 to the power of 2 times 5/6 to the power of 2, which is already there. And so we have a 25 out of 216 chance of rolling exactly 2 3s when we roll a die 4 times. Okay. What about getting all 5s? So you're rolling a dice 1, 2, 3, 4 times. It's the same thing as rolling 4 dice 1 time. This is almost like Yahtzee. What's the probability of getting all 5s? So all of them means exactly 4, right? If we want all 4 of them to be 5s, you need 4 5s. So we're still rolling the dice 4 times. That's our activity. We want to get 4 5s, and your probability of getting a 5 on a roll of a dice is still 1 in 6. So the probability of not getting a 5 is 5 in 6. So we're going to do NCR times P to the R times Q to the N minus R. 4 minus 4 is 0. So there's our setup. So 4C4 times 1/6 to the 4th and 5/6. Anything to the 0 power is just 1, so you really don't even have to put that, but we will. So you have a 1 in 1,296 chance of getting all 5s. This is theoretical probability, a 1 in 1,296. What about getting no 5s? Or exactly how many? If you get no 5s, you're getting exactly 0 5s if you get no 5s on the dice. So you got to kind of think about what no 5s mean, 0. So you're still rolling the dice 4 times. Your R value is what comes after the word exactly, so R is 0. We don't want any 5s. The probability of getting a 5, now don't even think about what this no means or this exactly 0, because what we're trying to figure out is what's the probability of getting a 5 on a roll of a dice. It's still 1 in 6. And the Q value, the probability of not getting a 5 is 5 in 6. So do not confuse the R value with the P and the Q. They have nothing to do with each other, not anything. Even though this is 0, your P and Q value still is a probability of getting a 5 on one roll of a dice. And this sometimes confuses students, but don't mix those up at all. So we have 4C0 this time. 4C0, oh, I haven't written it down. NCR is 4C0 times 1/6 to the to the 4th power times 5/6 to the 4 minus 0. P to the R. So 1/6 to the 0 power, 5/6 to the 4 minus 0. So 4C0 times 1/6 to the 0 times 5/6 to the 4th. And the probability that we won't get any 5s on our 4 rolls of a dice is 625 over 1296. So there's a better possibility that we won't get any 5s at all versus getting all 4 of them being 5s, which hopefully makes sense to you logically. Okay, a couple more. Now we're manufacturing cars. And in this car manufacturing plant, 2 out of every 10 cars are red. So if 20 cars are randomly selected, what's the probability that exactly 3 of them are red? So now we have to think to ourselves, okay, this is an NCR, P to the R, Q to the R, N minus R question. So the number that comes after the word exactly is going to be our R value. R is equal to 3. Now 20 cars are randomly selected, so the total of 20 cars would be our N value, and the probability that the cars will be red is 2 out of 10. So the P value being 2 out of 10, well, 2 out of 10 is the same thing as 1 over 5. And don't confuse this question with the previous one. I should write it down here. So N is 20 because we have 20 cars. R is exactly 3. The probability that a car is red is 2 in 10, which is 1 in 5. And the probability that that car is not red is 4 in 5. So what's that probability? NCR, so we should have a 20C3, which occurs here and here. It must be one of these two, times P to the R, which is 1/5 to the third, times 4/5 to the 20 minus 3. So we should have 20C3 times P to the power of R times Q to the power of N minus R, which is 17. Well, which one of these? It's not this one. I think it's this one, 20C3. It really doesn't matter which order we put that in. This is 4/5 to the 17, which we have here, and 1/5 to the third. It looks like it's option number 2. This was a Regents question a few years back, or maybe recently. All right. So you got to look for the keywords in these problems. Okay, and then the last one that we're going to do today is which one has a greater probability answering 4 out of 5 questions correctly on a multiple choice test where each question has 4 choices, or answering 3 out of 5 questions correctly on a multiple choice test where each question has 5 choices. Explain your answer. Well, now we have to figure out the probability of each one. So let's say this is our A version, the 4 out of 5 questions on the first multiple choice test, and then this is our B version, so we can kind of separate our logic. So we have N, R, P, and Q. So what's the probability of answering 4 out of 5 questions correctly on a multiple choice test where each question has 4 choices? Well, how many total things are we doing? We are answering 5 total questions. And R is the number of successes we're looking for. Well, we want to be successful 4 times out of the 5 questions that we're answering. So R is the number of successes we want. We want to be successful 4 times out of the 5 questions that we're choosing. Okay, now, so what is the p-value? If this multiple choice test has 4 choices, so let's say each choice has A, B, C, and D, and you're just guessing. So your chance of getting it right is a 1 in 4 chance because each question has 4 choices. So that must mean your Q value is 3/4 because these always have to add up to 1. So that's your situation A. Well, situation B, I want to answer 3 out of 5 questions correctly. So the total number of questions I have to work with is 5. The number of successes, I want to be successful 3 times out of 5. Whoops. Oh boy. What is the probability that I'm going to be successful? Well, my multiple choice test question has 5 choices now. So if I'm just totally guessing, I have a 1 in 5 chance of getting that question right. And since P and Q add up to 1, my Q value must be 4/5. So now I'm going to figure out which one of these two has the greater probability. So on this one, we have 5C4 times 1/4 to the 4, P to the R, times Q to the N minus R, which is 1. So let's see what that is. C4 times 1/4 to the 4 power times 3/4 to the 5 minus 4, which is 1. So we have a 15 out of 1024 chance of getting 4 out of 5 questions right on the A situation. Now on B. B, I only need to get 3 out of 5 questions right in order to be successful, but now my p-value is I have a 1 in 5 chance of getting it right. Oh, so let's write this down first before I plug it in the calculator. 5c3 times p to the r times q to the 5 minus 3, which is 2. So we have 1/5 to the third power. And this time we have 4/5 to the second power. And this is a 32 in 625 chance. So I don't know how to compare those two fractions unless I actually do the division. So let me divide 15 divided by 1024, and that is a 0.0146, about approximately 0.0146. And 32 divided by 625 is 0.0512. 0.0512. Well, 0.0512 is bigger than 0.0146, so the answer is situation B. 3 out of 5 questions correctly, you have a better chance of that because you have a 5% probability and you only have a 1.5% probability. So I will say situation B. B has a better probability. Because it has a higher probability. This is a greater probability than the other one. So sometimes you have to just do a little bit more math on these, but like I said, the most important thing is for you to memorize this formula and to know how to get N, R, P, and Q and to be able to plug it in correctly. And that's it for today.